Now let's take a look at division involving radicals. Now what's interesting is that we don't actually divide radicals. The problem with radicals is we don't want to leave a root in the denominator. So we don't want a radical in the denominator. The question is, how do we get rid of it? Well, if we're getting rid of a root in the denominator, there's a fancy term for this. It's called rationalizing. It's okay if there is a root in the numerator in the top, but not okay if it's in the denominator. Now, you can't just square the top and the bottom of the fraction. That would be nice, but you can't, because then you'd be multiplying the top and the bottom by different things. And we know that if you do something to a fraction, whatever you do to the bottom, you have to do that same exact thing to the top, not something different. So let's take a look at A and see how we're going to do this. So in A, we have 11 over the square root of 11. The problem with this answer is that there's a square root in the denominator. We have a square root of 11. So the question is, what do I do to get rid of a square root of 11? Well, we've seen that if you multiply by its identical matching twin, it will cancel out the square root. So that's an idea. So let's do that to the bottom. But then if I do it to the bottom, I have to do the same thing to the top. So let's see what happens. So on the bottom, when I multiply the square root of 11 times the square root of 11, I get, well, the square roots will cancel out and just leave me with 11 on the bottom. On top, I end up with 11 times the square root of 11. There's no pretty way to write that other than 11 square roots of 11. Now notice, I don't have a square root on the bottom. That was my goal, so I achieved it. The only question now is my answer reduced? And the answer is no, it's not. Why? Because I have an 11 on the top and 11 on the bottom, and they're both on the outside of the root. They either have to both be inside or both be outside to be considered the same type of thing. But because they're both on the outside of a root, I can actually reduce them normally and they will cancel out, which means my final answer is just this part, the square root of 11. That's my final answer. And that's okay because the square root of 11 is on the top. As long as my square root isn't on the bottom, that's all I care about. Let's take a look at problem B. We have the square root of 5 over the square root of 3. Again, there's only one of these that I am actually worried about. I am worried about the fact that I have a square root on the denominator. So I'm worried about the square root of 3. How do I get rid of the square root of 3? I'm going to multiply it by its twin, another square root of 3. But if I do that to the bottom, I have to do the exact same thing to the top. I have to multiply the top by another square root of 3. Let's see what that does for me. What that does on the bottom is I've got the square root of 3 times the square root of 3, which is just 3. It will cancel out the square roots. And let's see, on top, I will end up with the square root of 5 times the square root of 3, which is the square root of 15. And the square root of 15 does not reduce at all because it's just 5 times 3. You can't take the square root of 5 nor the square root of 3, so you're stuck with the square root of 15. And what I cared about was that I don't end up with a square root on the bottom, and I don't have one anymore. So that's all I can do, and I'm all done. My final answer is the square root of 15 over the square root of 3. Let's try another one. In C, we've got 3 square roots of 2 over the square root of 11. So my problem on C is that I've got a square root of 11 in the denominator. I don't want a square root in my final answer, so how do I get rid of the square root of 11 in the denominator? I'm going to multiply the bottom by a square root of 11. If I do that to the bottom, though, I have to also do it to the top. multiply it by a square root of 11. So let's see what happens. On the denominator, I've got the square root of 11 times the square root of 11. The square roots will cancel out, leaving you with just an 11. And on top, let's see, I've got my 3 that was out in front. That's still going to be out in front. Now I just have to worry about what's the square root of 2 times the square root of 11. Well, they're both underneath the square root, so they'll stay underneath the square root as 2 times 11, which is 22. Now, it would be awfully tempting to divide the 11 into the 22, but you can't, because the 11's on the outside of the root and the 22's on the inside. I always think of the square root as a big divider. I cannot cross that barrier of the square root if I've got some stuff on the inside and some stuff on the outside. You can only match up stuff on the inside with stuff on the inside, and stuff that's on the outside can only match up with other stuff that's on the outside of the root. The square root's like a big barrier. You can't pass through it unless you can somehow break something off that you can take the square root of. And notice that 22 can only be broken down into 2 times 11. And you can't take the square root of 2, and you can't take the square root of 11. So there's really nothing we can do here. It is as simplified as it can get. 3 can't reduce, 11 can't reduce, and the square root of 22 can't reduce either. So we are done. This is our final answer of 3 square roots of 22 over 11. And this is okay because there's no square root in the denominator. That's all we really cared about. Let's look at problem D.